Hello, in this lecture we will find out the area of the green shape in three different methods. In the drawing we have rectangle ABCD. We know that line segment EB equals to 7 units, line segment BF equals to 9 units, and also we know that AE equals to ED. We also know that angle ABE equals to theta, and also angle EBF also equals to theta. So actually ABCD is a rectangle and we want to find out the area of the green shape. So in the first method we will extend line segment BE and also line segment CD until they touch each other. So we'll extend line segment BE and we will also extend side CD of the rectangle until it intersects with the extended line segment BE. We will define the touching point between the extended BE and the extended CD. We will define this point as point P, and we actually know that CD, it is one side of rectangle ABCD, therefore it is a straight line, and we extended the straight line CD by straight line, so CP will be still a straight line. So CP is a straight line, and we also know that all the angles inside a rectangle are right angles, so this angle is equal to 90 degrees, it is a right angle, and this angle also equals to 90 degrees, is also a right angle, and this angle, it is also a right angle, it equals to 90 degrees, and we arrive to the conclusion that CP is a straight line, so I write it down. We arrived to the conclusion that line segment CP is a straight line. CP is a straight line. And we actually have a rule, I call it rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 100 80 degrees. Okay. So I will read rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So we arrived to the conclusion that CP is a straight line
trapeze,
so we arrived to the conclusion that line segment CP is a straight line. So according to rule number 1, if you focus on this side of the straight line CP at point D, the sum of the angles must be equal to 180 degrees. So which angles we have at point D, at this side of the straight line CP at point D, we have this angle is 90 degrees, and this angle PDE, we define this angle as angle X. So X plus 90 degrees must be equal to 180 degrees according to rule number 1. So X plus 90 degrees must be equal to 180 degrees according to rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So we will subtract 90 degrees from this equation, and we will get that angle X equals to 180 degrees minus 90 degrees, it equals to 90 degrees. So angle X is a right angle, so we can substitute X by a right angle. Angle X is a right angle. And actually we know that the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to CD. We know that AB is parallel to CD according to the rule that the opposite sides of a rectangle are parallel to each other. Therefore, AB is parallel to CD in rectangle ABCD. But if AB is parallel to CD, then AB will be also parallel to CP, because we extended CD, that is a straight line by straight line. So CP is located on the same straight line that CD is located. So CP is actually on the same straight line that CD is. Therefore, if AB is parallel to CD, then AB will be also parallel to CP. So actually AB is parallel to CP. Okay, if we have two sides that are parallel to each other, then they will be parallel all if we have the extended for example, if CD is a straight line, we extended CD by a straight line, so it is still the same straight line. CP is the same straight line as CD, therefore if AB is parallel to CD, then AB will be parallel also to CP. Okay, and we have also rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. So I read rule number 2 again. According to rule number 2, alternating angles between parallel lines are equal to each other. And we know that AB is parallel to CP. We know that AB is parallel to CP. So actually those two angles are defined as alternating angles, and they are located between the parallel lines AB and PC. Therefore, they are equal to each other according to rule number 2. That is to say, this angle, that is angle ABE, equals to angle DPE according to rule number 2. Angle ABE equals to angle DPE according to rule number 2. Repeat again. Angle ABE equals to angle DPE according to rule number 2, that alternating angles that are located between parallel lines are equal to each other. Those two angles are defined as alternating angles and they are located between the parallel lines AB and PC, therefore they are equal to each other. But we know that angle ABE equals to theta. It is given us in the question. Angle ABE equals to theta according to what is given us in the question. So therefore, from this equality we will conclude that angle DPE also equals to theta. Angle DPE also equals to theta. So actually this angle DPE also equals to theta. So in the next step we will prove that those two triangles, right angles, can go into each other. Okay, so we will focus on the right green triangle, triangle ABE. and on the right green triangle, triangle EPD. And we will prove that those two right triangles can go into each other. Okay. First of all, we just right now proved that those two angles, they are equal to each other, they are both equal to theta. So angle ABE, this angle, of triangle ABE equals to angle EPD of triangle EPD, and both those two angles are equal to theta. I'll repeat again. Angle ABE equals to angle EPD, and both those two angles are equal to theta. And those two angles, they are both right angles, therefore they are equal to each other. So angle BAE, this angle, equals to angle EDP, and both those two angles are equal to 90 degrees. I will repeat again. Angle BAE equals to angle EDP, and they are both equal to 90 degrees. And we have also those two angles are vertex angles, and they are equal to each other according to the rule that vertex angles are equal to each other. So angle AEB equals to angle PED, this angle PED, according to the rule that vertex angles are equal to each other. I'll repeat again. Angle AEB equals to angle PED. So those two angles, they are equal to each other according to the rule that vertex angles are equal to each other. So we actually proved that all the angles of triangle ABE can go into all the angles of triangle PDE. And we also know that AE equals to ED according to what is given us in the question. So AE equals to ED is given us in the question. Then AE equals to ED according to what is given us in the question. So actually we proved that those two triangles can go into each other according to angle side angle rule. So triangle ABE can go into to triangle EPD. So this is the sign of congruent. Triangle ABE can go into triangle EPD according to angle side angle rule. Okay. So what is angle side angle rule? Angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent to two angles and the side that included then the triangles congruent to each other according to angle side angle rule. So I repeat on angle side angle rule again. If two angles and the side that included between those two angles in one triangle congruent to two angles and the side that included, then the triangles congruent to each other according to angle side angle rule. And we actually proved that those two angles and side AE that is included between those two angles in triangle AEB congruent to those two angles and side ED that is included between those two angles in the right triangle, triangle EPD. Therefore, we proved that those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that BE equals to EP. BE equals to EP. Okay. BE equals to EP according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, those two corresponding sides, that is to say, those two triangles congruent to each other. Therefore, those two corresponding sides, that is to say PE and EP, will be equal to each other. But we know that BE equals to 7 units. It is given us in the question that BE equals to 7 units. Okay, so from this equality, we will conclude that EP also equals to 7 units. EP also equals to 7 units. So EP equals to 7 units. And actually, we will define the area of quadrilateral BEDF. The area of this quadrilateral BEDF is Y. The area of quadrilateral BEDF is Y. According to our definition, the area of quadrilateral BEDF equals to Y. And we will define the area of the right green triangle ABE as X. And because of the fact that those two triangles can go into each other, they have also the same area. So if the area of triangle ABE is X, then the area of triangle EPD will be also equals to X. So the green area that we have to find is equal to X plus Y. The green area equals to X plus Y. Repeat again. The green area that we have to find is equal to X plus Y, but the area of triangle BPF, the area of triangle BPF also equals to X plus Y. The area of triangle BPF also equals to X plus Y. Again, the area of triangle BPF also equals to X plus Y. So we actually can find out the area of triangle BPF, and in this way we will find out the area of triangle, the area of the green area, because of the fact that those two areas are equal to each other. Okay? So we have also know that triangle BPF, this triangle BPF is an isosceles triangle. Why? Because it has two angles that are equal to each other. Those two angles are both equal to theta, therefore triangle BPF is an isosceles triangle. So we can write down that triangle BPF is an isosceles triangle. I will repeat again. Triangle BPF is an isosceles triangle because of the fact that it has two angles that are equal to each other. They are both equal to theta, those two angles. And we also have rule number 3, according to rule number 3, the median to the base of an isosceles triangle is perpendicular to it. Okay? The median to the base of an isosceles triangle is perpendicular to the base. I repeat again on rule number 3. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle ABC, so here triangle ABC is an isosceles triangle. Why? Because it has two angles that are equal to each other, they are both equal to theta. Therefore, actually, the base of the isosceles triangle ABC is BC. And if from the vertex point A, we will draw median to the base BC, and we will define the touching point between the median to the base BC as point O. So AO as the median to the base BC bisects BC. That is to say, BO equals to CO. BO equals to CO. So if BO equals to X, then CO will be also equal to X. And according to rule number 3, because of the fact that triangle ABC is an isosceles triangle, then the median AO to the base BC is perpendicular to the base BC. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? So the median AO to the base BC of the isosceles triangle ABC is perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So we actually can implement rule number 3 in our drawing. We have the isosceles triangle BPF. It is an isosceles triangle because it has two angles that are equal to each other. They are both equal to theta. So the base is BP. So if from point F we will draw median, so the median will be FE. Why the median FE? Because actually FE bisects BP into two equal parts. That is to say, BE equals to EP equals to 7 units. So BE equals to 7 units and EP also equals to 7 units. And according to rule number 3, the median FE to the base BP in the isosceles triangle BPF is perpendicular to the base BP. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so those two angles are right angles according to rule number 3. And because of the fact that this angle is a right angle, then the green triangle BEF is a right triangle. So we will focus on the right triangle B, the right green triangle BEF, on the right green triangle BEF, according to the Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. And actually, the hypotenuse in the right triangle BEF is BF because it is in front of the right angle. So the square of the hypotenuse is BF squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BE squared plus EF squared. So I'll repeat again. In the green right triangle BEF, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BF square equals to BE square plus EF square. Okay? But it is given us in the question that BF equals to 9 units. So BF square is 9 square. 9 square is 81 and it equals to BE square. It is given us in the question that BE equals to 7 units. If BE equals to 7 units, then BE square is 7 square. 7 square is 49 plus EF square. So in conclusion, I found out that 81 equals to 49 plus EF square. We will subtract 49 from equation number 1 and we will get that 41 minus 49 is 32. So EF square equals to 32. We will take out the root of this equation number 1, and we will get that EF equals to the square root of 32, but 32 is 16 times 2, so I write it down. 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that EF equals to 4 times square root of 2 units, so write it down. We found out that EF equals to 4 times square root of 2 units. So we'll write here that actually the height EF equals to 4 times the square root of 2 units, and we have already found out that BP is 7 plus 7, that is to say it equals to 14 units. So the area of the isosceles triangle BPF equals to the base of the triangle, that is actually BP, times the height to the base, that is actually EF, over 2. That is actually the formula for the area of any triangle. I repeat again, the area of the isosceles triangle BPF equals to the base of the triangle times the height to the base over 2. Okay, and so I already said the base is BP of the isosceles triangle BPF is BP the height is EF over 2. In conclusion, we found out that the area of the isosceles triangle BPF equals to BP times EF over 2. So the area of the isosceles triangle BPF equals to BP, that is 7 plus 7, it is 14 units, times EF, that is actually 4 times 2 units, over 2. So in conclusion, the area of the isosceles triangle BPF equals to 14 times 4 times square root 2 over 2. 14 over 2 is 7, so I write it down. So the area of the isosceles triangle BPF equals to 7 times 4 times square root of 2, and 7 times 4 is 28, so we found out that the area of the isosceles triangle BPF equals to 28 times square root of 2 square units. That is actually also the green area. It is also the green area. So in conclusion, we found out that the area of the isosceles triangle BPF that is also equals to the green area that we are looking for is equal to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. We finished with the first method. And we will I present to you the second method to find out the area of the green shape. So in the second method, we actually know that AB is parallel to DC according to the rule that the opposite sides of a rectangle, and ABCD is a rectangle, the opposite sides of a rectangle are parallel to each other, therefore AB is parallel to DC, and if AB is parallel to DC, therefore AB will be also parallel to FC. So we can write down that AB is parallel to FC. AB is parallel to FC. AB is parallel to FC. Again, AB is parallel to FC, and according to the rule that I have already mentioned, that alternating angles between parallel lines are equal to each other, those two angles are defined as alternating angles, and they are located between the parallel lines AB and FC. Therefore, they are equal to each other. That is to say, those two angles are equal to each other. This angle is theta plus theta is 2 theta. It equals to this angle. So, this angle must also equal to 2 theta. Again, according to the rule that alternating angles between parallel lines are equal to each other. Those two angles are defined as alternating angles. And because of the fact that they are located between the parallel lines AB and FC, they are equal to each other, as I already mentioned in the first method. So this angle is equals to 2 theta, and we also know that all the angles inside the square are right angles. Therefore this angle is a right angle, it equals to 90 degrees. This angle, it is also a right angle, it equals to 90 degrees. And this angle also equals to 90 degrees, because ABCD is a rectangle. Okay? We will define AE, this line segment, as X, and we know that AE equals to ED. AE equals to ED. So if AE is X, then ED will be also equal to X. Okay? And we also know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to BC. But what is the value of AD? The length of AD is x plus x, that is to say AD equals to 2x. And it equals to BC. So if AD equals to 2x, then BC also will be equal to 2x. Okay? And we will focus on the right triangle, triangle ABE. Okay? On the right triangle, triangle ABE, this right triangle, green triangle, ABE, this angle is theta. So here we know that BE equals to 7 units. Is given us in the question. We defined AE as x. So I do again the right triangle, triangle ABE. This angle is a right angle. So in this right triangle, triangle ABE, we know that sinus theta equals to x over 7. Sinus theta equals to x over 7. And in the right triangle, triangle BFC, this right triangle, lower triangle, the right triangle BFC, sinus 2 theta equals to, I will shorten the process. Instead of saying sinus theta equals to BC over BF, but we know, I will say immediately that sinus 2 theta equals to 2x over 9, okay? Sinus 2 theta equals to 2x over 9. I want to save time. So we actually have here two equations. The first equation is sinus theta equals to x over 7. Equation number 2 states that sinus 2 theta equals to 2x over 7. But we have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosine theta. Okay. So we can substitute sinus 2 theta from equation number 2 by 2 sinus theta cosine theta. So we will do it. So 2 sine theta cosine theta equals to 2x over 9. Here we have sinus theta, and from equation number 1 we know that sinus theta equals to x over 7. So we will substitute sinus theta we will substitute sinus theta from this equation number 2, by x over 7 from equation number 1, because sinus theta equals to x over 7 according to equation number 1, and we will get that 2 sinus theta equals to x over 7 according to equation number 1 times cosine theta equals to 2x over 9. Okay, here we have 2x on both sides of equation number 2, so 2x will get cancelled. And what is left after we cancel 2x from equation number 2? What is left? It is actually 1 over 7 times cosine theta, that equals to 1 over 9. So here we will multiply this equation number 2 by 7 in order to get the value of sine theta, of cosine theta. We will get that according to equation number 2, cosine theta equals to 7 over 9. We found out that cosine theta equals to 7 over 9. What does it mean? Actually, cosine theta is the relationship between the side that is near angle theta over the hypotenuse of a right triangle. This is the function cosine expresses the relationship between the sides of a right triangle. So if we have right triangle, this angle equals to 90 degrees. This angle is angle theta. So if this angle is angle theta, then cosine 7 over 9 means that the side that is near theta equals to 7 units and the hypotenuse equals to 9 units. This is the expression. Actually, I drew the expression, equation number 2, that cosine 2 theta equals to 7 over 9. This is what it really means, that in a right triangle that has one angle that equals to theta, the side that is near angle theta equals to 7 units and the hypotenuse equals to 9 units. So what is the value of the side that is in front of angle theta? We will define it as S, and according to the Pythagoras theorem, S squared plus 7 squared equals to 9 squared. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. S squared equals to 9 squared is 81, minus 7 squared is 49, s squared equals to 81 minus 49 is 32. So s equals to square root of 32. 32 is 16 times 2. Square root of 16 is 4. In conclusion, we found out that s equals to 4 times square root of 2. So actually we know that if cosine theta equals to 7 over 9, then sine theta, from this drawing you can see that sine theta equals to 4 times square root of 2 over 9. Okay, so we actually found out the values of we know that cosine theta equals to 7 over 9 and sine theta equals to 4 times square root of 2 over 9. Okay, so I will draw again the right triangle ABE, and we will find out the value of x and the value of AB. The right triangle ABE is actually here. So actually this is the right triangle ABE. We will find out the value of x. We know that sine theta equals to x over 7. Sine theta equals to x over 7. This is actually according to equation number 1. But we have already found out that sine theta equals to 4 times square root of 2 over 9. So we can substitute sine theta by 4 times square root of 2 over 9. And in this way, we will have only one variable that is missing, that is actually x. In this way, we will find out the value of x. We will multiply this equation number 1 by 7, and we will get that 28 times square root of 2 over 9 equals to x. So we found out that x equals to 28 times square root of 2 over 9 units. Okay, so we can write here that x equals to 28 times square root of 2 over 9. Here also x equals to 28 times square root of 2 over 9. If x equals to 28 times square root of 2 over 9, then 2x will be equal to 56 times square root of 2 over 9. And we know that AD equals to x plus x, so AD also equals to 56 times square root of 2 over 9. Okay, AD equals to x plus x, that is, so it equals to 56 times square root of 2 over 9, and it also equals to BC. So we will continue to focus on the right triangle ABE, and we will find the value of AB. As you can see, in this right triangle, cosine theta equals to AB over 7. Okay, cosine theta equals to AB over 7. Cosine theta equals to AB over 7. But we have already found out that cosine theta equals to 7 over 9. So we'll substitute cosine theta by 7 over 9. So 7 over 9 equals to AB over 7. We will multiply this equation by 7, and we will get that AB equals to 7 times 7 is 49 over 9. So we found out that AB equals to 49 over 9. Okay, AB equals to 49 over 9. And because of the fact that the opposite sides of a rectangle are equal to each other, in rectangle ABCD, it means that AB equals to DC. And if AB equals to 49 over 9, then DC will be also equal to 49 over 9. Okay? So DC equals to 49 over 9. In the next step, we will focus on the right triangle BFC. On the right triangle BFC, this right triangle BFC, cosine 2 theta equals to FC over the hypotenuse, that is 9. Okay? In the right triangle BFC, BFC, we know that cosine 2 theta equals to FC over 9. We will multiply this equation by 9, and we will get that FC equals to 9 times cosine 2 theta Okay. We found out that fc equals to 9 times cosine 2 theta, and according to the trigonometric identity that cosine 2 theta equals to 2 cosine square theta minus 1, so we can substitute cosine 2 theta by 2 cosine 2 theta by 2 cosine square theta minus 1, because they are equal to each other. So we get that fc equals to 9 times, and cosine 2 theta equals to 2 times cosine square theta minus 1. We have already found out that cosine theta equals to 7 over 9, so we can place the value of cosine theta inside cosine square theta in this equation, and we will get that fc equals to 9 times 2 cosine square theta. Cosine theta is 7 over 9, so cosine square theta will be equal to 7 over 9 square minus 1. Okay, so actually the value of fc is equal to 9 times 2 times 7 square is 49 over 9 square is 81, and minus 1 is 81 over 81, or minus 1 is minus 81 over 81. So in conclusion, we got that fc equals to 9 times 2 times 49 minus 81 over 81. 2 times 49 is 98, so I write it down, so we get that 9 times 2 times 49 is 98, so 2 times 8, so it is 98 minus 81 over 81. So fc, we will divide the numerator and the denominator by 9. 9 over 9 is 1, so here we left only with 98 minus 81, and 81 over 9 is 9. In conclusion, we got that fc equals to 98 minus 81 over 9, that is to say fc equals to 17 over 9. So we found out that fc equals to 17 over 9. fc, we can write here that fc equals to 17 over 9. And what is the value of df? The value of df is dc minus fc. dc minus fc equals to df. Okay, I'll repeat again. df equals to dc minus fc. that is to say df equals to dc. We have already found out that dc equals to 49 over 9 minus fc. We have already found out that fc equals to 17 over 9. So actually, we found out that df equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32. So in conclusion, we found out that df equals to 32 over 9. df equals to 32 over 9. So we can write here that df equals to 32 over 9. And we actually found out the values of all the sides of trapeze, the trapeze ABFD. So we can easily find out the area of trapeze ABDF. The area of trapeze ABDF will be equal to AB plus DF times the height, that is AD, over 2. I'll repeat again, the area of the green shape is the area of trapeze ABDF, that is actually equals to the area of the trapeze ABDF equals to the sum of its sides times the height over 2. The sum of its sides is AB plus DE, the height is AD over 2. So the area of trapeze ABDF, that is the area of the green shape, equals to AB is 49 over 9 plus DF is 32 over 9 times AD. AD is 56 times square root of 2 over 9, all divided by 2. I'll repeat again, so the area of trapeze ABDF equals to this expression. 49 plus 32 is 81. So we get that the area of trapeze ABDF equals to 81 over 9 times 9 times 56 times square root of 2 over 2. Here we have 9 times 9 is 81. And 81 over 81 is 1. So this expression will get cancelled. So we found out that the area of the green shape ABDF, the trapeze ABDF, equals to 56 over 2 is 28. So the area equals to 28 times square root of 2 square units. Or in terms of numbers, it equals to 39.6 square units. I'll repeat again. We found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the second method. So we will start with the third method. So in the first method, we will draw perpendicular from point E to BF. So this angle will be equal to 90 degrees. And this angle will be also equal to 90 degrees because this is a perpendicular. We define the touching point between the perpendicular from E to BF as point M. And we know that all sides inside the rectangle are right angles. All the angles inside the rectangle are right angles, so this angle equal to 90 degrees. And this angle also equals to 90 degrees. And this angle also equals to 90 degrees. So in the next step, we will prove that those two right angles can go into each other. That is to say that the right triangle ABE, this right triangle is congruent to the right triangle BME. So why they can go into each other? First of all, we know that those two angles, they are equal to each other, they are both equal to theta. So we can write down that angle ABE, or triangle ABE, is equal to angle EBM, or triangle EBM, and they are both equal to theta. So I repeat again. Angle ABE of triangle AB equals to angle EBM of triangle EBM, and they are both equal to theta. Both those two angles are equal to theta. Those two angles, they are both right angles, therefore they are equal to each other. So angle BAE equals to angle BME, and they are both equal to 90 degrees. I'll repeat. Angle BAE equals to angle BME, and they are both equal to 90 degrees. And those two angles, they are equal to each other. Those two angles, they are equal to each other according to third angle theorem. So angle BEA equals to angle BEM. They are equal to each other according to third angle theorem. I'll repeat again, angle BEA equals to angle BEM according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we found out that those two angles in the right triangle, triangle BAE, congruent to those two angles in the right triangle, triangle BEM. Therefore, those that are the first pair of angles must also congruent according to number 3, therefore they are equal to each other. Okay, so we found that all the angles inside triangle BAE are congruent to all the angles of triangle BEM. And we also know that BE equals to BE, it is a common side. That is to say it belongs to both triangles. Again, BE equals to BE is a common side that belongs to both triangles. So we actually proved that triangle BAE congruent to triangle BEM according to angle side angle rule. I'll repeat again, we actually proved that triangle BAE congruent to triangle BEM according to angle side angle rule, and I've already explained to you what is angle side angle rule, so I will not repeat on it. From the fact that those two triangles congruent to each other, we will conclude that AB equals to BM, AB equals to BM, so actually AB equals to BM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say AB and BM, will be equal to each other. And if we define AB as Y, then so AB equals to Y according to our definition. So from this equality we will conclude that BM also equals to Y. BM equals to Y. BM equals to Y. We know that BF equals to 9 units. BF equals to 9 units. BM equals to Y. So MF will be equal to 9 minus Y. We will also conclude that AE equals to ME. AE equals to ME or EM. AE equals to EM according to the rule that corresponding sides in congruent triangles are equal to each other. And if we define AE as x, then EM will be also equal to x. And because of the fact that AE equals to ED, according to what is given us in the question, AE equals to ED. So if A equals to x, then ED will be also equal to x. Okay? In the next step, we will join together points E and F by a straight line. And we will prove that those two right triangles can go into each other. That is to say that the right triangle EMF can go into the right triangle EDF. Okay? First of all, those two angles, they are both right angles, therefore they are equal to each other. So angle EMF, equals to angle EDF, this angle, and they are both equal to 90 degrees. Again, angle EMF equals to angle EDF, and they are both equal to 90 degrees. EM equals to ED equals to x. We've already proved it. EM equals to ED, they are both equal to x according to our definition. EM equals to ED equals to x. And EF equals to EF. EF equals to EF. It is a common side that belongs to both triangles. EF equals to EF. It's a common side that belongs to both triangles. So actually, we proved that in those two right triangles, that the hypotenuse and the perpendicular EM in this right triangle can go into the same hypotenuse and the perpendicular in this the perpendicular ED in this right triangle. And we have actually rule number 5. According to rule number 5, if the hypotenuse and a perpendicular in two right triangles congruent, then the two right triangles can go into each other. So I will read rule number 5 again. According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the two right triangles congruent to each other. And I repeat again, we actually proved that the hypotenuse EF and the perpendicular EM in the right triangle EMF congruent to the hypotenuse EF and the perpendicular ED in the right triangle EDF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. So you can write down that triangle EMF congruent to triangle EDF according to rule number 5. I'll repeat again. We proved the right triangle EMF congruent to the right triangle EDF according to rule number 5. From the fact that those two right triangles congruent to each other, we will conclude that MF equals to FD. MF equals to FD. Again, MF equals to FD according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say MF and DF, will be equal to each other. But we know that MF equals to 9 minus Y. So we can write down that MF equals to 9 minus Y. From this equality, we will conclude that FD also equals to 9 minus Y. So we can write down that FD equals to 9 minus Y. And according to the rule that the opposite sides of a rectangle are equal to each other, so in rectangle ABCD, AB equals to DC. AB equals to DC. So, but we know that AB equals to Y according to our definition. So if AB equals to Y, then DC will be also equal to Y. DC also equals to Y. So we know that DC equals to Y. DC equals to Y. DF equals to 9 minus Y. And what is the value of FC? FC equals to DC minus DF. Again, DC minus DF equals to FC. I write it down. DC minus DF equals to FC. Okay, DC minus DF equals to FC. So FC equals to DC, that is Y, minus DF, that is 9 minus Y. So in conclusion, we found out that FC equals to Y minus 9 minus Y. We will open the brackets and we will get that FC equals to Y minus 9 minus Y is plus Y. In conclusion, we found out that FC equals to Y plus Y is 2Y minus 9. FC equals to 2Y minus 9. So we can write here that FC equals to 2Y minus 9. And again, according to the rule that the opposite sides of a rectangle are equal to each other, it means that in rectangle ABCD, AD equals to BC. But AD equals to x plus x, that is to say AD equals to 2x. So if AD equals to 2x, then BC will be also equal to 2x. Okay? So we will focus on the right triangle, triangle ABE. In the right triangle, triangle ABE, according to the Pythagoras theorem, we will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BE square, BE is 7, so BE square is 7 square, 7 square is 49, equals to AE square, AE is x, so AE square is x square, plus AB square, AB is y, so AB square is y square. So we actually found out that x square plus y square equals to 49, according to equation number 1. I will repeat again. We actually found out that x square plus y square equals to 49, according to equation number 1. We will focus on the right triangle, triangle BFC. On the right triangle, triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BF. BF equals to 9 units. It is given us in the question that BF equals to 9 units. If BF equals to 9, then BF square will be equal to 9 square. 9 square is 81. And it equals to the sum of the squares of the perpendiculars. That is means that it equals to FC square. FC is 2y minus 9, so FC square will be equal to 2y minus 9 square, plus BC square. BC equals to 2x, so BC square will be equal to 2x squared, that is means it equals to 4x squared. So in conclusion, we found out that in the right triangle BFC, in the right triangle BFC, in the right triangle BFC, 81 equals to 2y minus 9 squared plus 4x squared. We will open the brackets in this side of equation number 2, and we will get that 81 equals to 2y minus 9 square equals to 4 9 squared plus 81 minus 36y plus 4x squared. Okay, so here we have 81 on both sides of equation number 2. So 81 will get cancelled. So 0 equals to, here we will take a common factor of 4 from those two expressions, and we will get that it equals to 4 times x squared plus y squared minus 36y. According to equation number 1, x squared plus y squared equals to 49, so we can substitute x squared plus y squared in equation number 2 by 49 from equation number 1. So we get that 0 equals to 4 times x squared plus y squared is 49 minus 36y. So we actually will get that according to equation number 2, (36y) equals to 4 times 49. So here we will divide equation number 2 by 4, and we will get that 36 over 4 is 9y. 9y equals to 49. We will divide the equation number 2 by 9, and we will get that y equals to 49 over 9. Y equals to 49 over 9. And according to equation number 1, x squared plus y squared equals to 49. So we will place the value of y from equation number 2 in y squared from equation number 1, and we will get that x squared plus y is 49 over 9, so it is 49 over 9 squared equals to 49. We will subtract 49 over 9 squared from this equation, equation number 1, and we will get that x squared equals to 49 minus 49 over 9 squared so we got that x squared equals to 49 minus 49 over 9 squared. 49 is 7 squared, so we write it down. We get that x squared equals to 7 squared minus 49 over 9 squared. We will use the trigonometric identity that a squared minus b squared equals to a plus b times a minus b. Here b squared is 0 and a equals to 7 and b equals to 49 over 9. Okay, so we will use this trigonometric identity. In equation number 1, we will get that x squared equals to a plus b times a minus b. A is 7 and b is 49 over 9, so a plus b is 7 plus 49 over 9 times a minus b is 7 minus 49 over 9. So in conclusion, we got this equation number 1. Okay, so actually x squared equals to, here we will multiply
Hello?
we will multiply
No avanti.
we will multiply 7 by 9, and then we will divide it by 9 in order to have a common factor with this expression, and we will get that x squared equals to x squared equals to, here it is 63 plus 49 over 9 times 63 minus 49 over 9. Okay. So x squared equals to 49 plus 63 over 9 times 63 minus 49 over 9. So x squared equals to 49 plus 63 is 112 over 9. 63 minus 49 is 14 over 9. So in conclusion, we found out that x squared equals to 112 over 9 times 14 over 9. 112 is 14 times 9, so we write it down. We got that x squared equals to 8 times 14 times 14 over 9 times 9. Eight is 2 times 2 times 2, so we write it down. X squared equals to 2 times 2 times 2 times 14 times 14 over 9 times 9. So here we will take a root out of this equation number 1, and we will get that x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9. So we found out that x equals to, here square root of 2 over 2 is 2, and square root of 14 times 14 is 14, and square root of 9 times 9 is 9. So in conclusion, we will get that x equals to 2 times 14 over 9. Inside the root, only 2 is left. So we found out that x equals to 2 times 14 over 9 times square root, that times square root of 2. That is to say, x equals to 28 over 9 times square root of 2 units, and we have already found out that y equals to 49 over 9. Y equals to 49 over 9. So the area of the ring trapeze is equal to the sum of its sides, that is to say AB plus DF times the height, that is AD, over 2. So the area of trapeze ABDF, that is also the area of the green shape, equals to AB plus DF times AD over 2. So the area of trapeze ABDF, or the green shape, equals to AB is Y, plus DF is 9 minus Y, times AD is 2x over 2. So we found out that the area of trapeze ABDF equals to Y minus Y is 0. 2 over 2 is 1. So the area of trapeze ABDF equals to 9x. The area of trapeze ABDF, or the green shape, equals to 9x. That is to say, it equals to 9 times x, and we have already found out that x equals to 28 times square root of 2 over 9. So here 9 over 9 is 1, so 9 will get cancelled, and we found out that the area of the green shape ABDF equals to either 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. I repeat again, the area of the green shape, according to method 3, equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay? Okay? So, in the next step I will summarize the lecture. We actually wanted to find out the area of the green shape, ABDF, and in method 1, or first method, we extended line segment BE and line segment CD until they intersect at point P. And we know that CD is one side of rectangle ABCD, therefore it is a straight line, and when we extended the straight line CD by straight line to CP, so CP will be still a straight line. And we also have rule number 1, so we know that CP is a straight line, and we have rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the straight line CP on this side of the straight line CP on point D, then the sum of the angles must be equal to 180 degrees. So this angle is right angle plus this angle that is defined as angle X must be equal to 180 degrees. According to rule number 1, angle X plus the angle is equal to 90 degrees must be equal in total to 180 degrees. So we subtracted 90 degrees from this equality and we got that angle x equals to 90 degrees. So we found out that this angle is a right angle, so we change it to a right angle. And then we know that AB is parallel to CD because the opposite sides of a rectangle are parallel to each other. So if AB is parallel to CD and CP is the extension of CD, then AB must be also parallel to CP because all the points C, D and P are located on the same straight line. And if the straight line AB is parallel to DC, then it will be parallel to the same straight line that is actually CP. CP is the same straight line as DC, therefore AB, if it is parallel to DC, will be also parallel to CP, that is also the same straight line. Okay, so AB is parallel to CP, and we have actually rule number 2 that alternating angles between parallel lines are equal to each other, and we know that AB is parallel to CP. Therefore, those two alternating angles that are located between the parallel lines AB and CP will be equal to each other. So if this angle is theta, then this angle will be also equal to theta. Okay, so according to rule number 2, angle ABE equals to angle DPE because those two angles are alternating angles and they are located between the parallel lines AB and CP, therefore they are equal to each other according to rule number 2. But we know that angle ABE equals to theta. From this equality we will get that angle DPE also equals to theta. So this angle equals to theta. Okay, then we proved that those two right triangles can congruent to each other. That is to say, triangle ABE is congruent to triangle EPD. Why that they congruent to each other? First of all, we know that those two angles, we just right now proved that those two angles are equal to each other, they are both equal to theta. So angle ABE equals to angle EPD equals to theta. Those two angles, they are both right angles, therefore they are equal to each other. That is to say, angle BAE equals to angle EDP equals to 90 degrees. And angle ABE equals to angle AEB equals to angle PED. Those two angles are equal to each other according to the rule that vertex angles are equal to each other. So we proved that all the angles inside the right triangle ABE can congruent to all the angles inside the right triangle PDE. And we also know that AE equals to ED because it is given us in the question. AE equals to ED, AE equals to ED, it is given us in the question. So we actually proved that those two right triangles, the triangle ABE can congruent to triangle EPD according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if two angles and the side that included between those two angles in one triangle congruent to two angles and the side that included, then the triangles congruent to each other according to angle side angle rule. And we actually proved that those two angles and the side that included, that is to say side EE, in the right triangle BAE congruent to those two angles, and the side that included ED in the right triangle PED. Therefore, we proved that those two right triangles congruent to each other according to angle side angle rule. And from the fact that those two right triangles congruent to each other, we will conclude that BE equals to EP. Okay, we will conclude that BE equals to EP according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles BE and EP will be also equal to each other. But we know that BE equals to 7 units. It is given us the question. From this equality, we will conclude that EP also equals to 7 units. Here, EP equals to 7 units. And we will define the area of quadrilateral EDFB as Y. The area of this quadrilateral EBFD is defined as Y. And we will define the area of the right triangle ABE as X. So the green area equals to X plus Y. The size of the green area is X plus Y. And we have to find the value of X plus Y. That is the size, that is the area of the green, that is the green area. But because of the fact that those two right triangles can congruent to each other, they have also the same area. So if this, the area of the right triangle ABE equals to X, then the area of the right triangle EPD will be also equal to X. And the area of triangle BPF equals to X plus Y, exactly the same of the green area. That is also X plus Y. So if we find the area of triangle BPF, that is X plus Y, we will find the green area that is also X plus Y. So we will find out the area of triangle BPF, and in this way we will find out the area of the green shape that is also X plus Y. Okay, the green area equals to X plus Y, and the area of triangle BPF also equals to X plus Y. So by finding the area of triangle BPF, we will find the green area. And we know that triangle BPF, this triangle, is an isosceles triangle. Why? Because it has two angles that are equal to each other. They are both equal to theta. Therefore, triangle BPF is an isosceles triangle. And we have rule number, rule number 3. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. Okay, what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle, triangle ABC is an isosceles triangle. Why? Because those two angles are equal to each other, they are both equal to theta. And the base of the isosceles triangle ABC is BC. If from point A we draw median to the base, so the median AO bisects BC into two equal parts. That is to say, BO equals to OC equals to X. And according to rule number 3, because of the fact that triangle ABC is an isosceles triangle, the median AO to the base also perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so we can implement rule number 3 in our drawing, because in our drawing we have an isosceles triangle, triangle BPF is an isosceles triangle because it has two angles that are equal to each other. So the median FE bisects the base BP. Why it bisects it? Because BE equals to EP equals to 7. So the median FE bisects the base BP of the isosceles triangle BPF, and according to rule number 3, the median to the base FE, it is also perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 3. And because of the fact that this angle equals to 90 degrees, then triangle BEF is a right triangle. We will implement the Pythagoras theorem on the green right triangle, triangle BEF. According to the Pythagoras theorem, in the right triangle, triangle BEF, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BF square equals to EB square plus EF square. BF equals to 9 units. So BF square is 9 square. 9 square is 81. And it equals to EB square. EB equals to 7 units. So EB square is 7 square. 7 square is 49. Plus EF square. EF is the missing variable. So we got that 81 equals to 49 plus EF square. We will subtract 49 from this equation, equation number 1. And 81 minus 49 is 32. So we got that according to equation number 1, EF square equals to 32. We took a root from this equation, equation number 1, and we found out that EF equals to square root of 32, but 32 is 16 times 2, okay? So EF equals to 16 times 2, the square root of 16 times 2, and the square root of 16 is 4, so in conclusion we found out that EF equals to 4 times square root of 2. EF equals to 4 times square root of 2. Here EF, that is actually the height to the base BP. It equals to 4 times square root of 2 units. And then we know that the area of any triangle, and especially triangle BPF, equals to the base of the triangle times the height to the base over 2. The base of triangle BPF is BP. The base is BP. The height is EF because it is perpendicular to the base. The base and the height is EF. So it is equals to BP times EF over 2. BP is 7 plus 7, that is to say 14. BP equals to 14 units. EF equals to 4 times square root of 2 units, and we will divide it by 2. So the area of triangle BPF, that is actually equals also to the green area, it equals to 14 times 4 times square root of 2 over 2 is 14 over 2 is 7. So in conclusion we found out that the area of the isosceles triangle BPF equals to 7 times 4 times square root of 2 units. So we actually found out that the area of the isosceles triangle, triangle BPF, that is also the green area, equals to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. That was method 1. Then we found the area of the green shape according to the second method. According to the second method, we actually know that AB is parallel to CD because ABCD is a rectangle. So if AB is parallel to CD, then AB will be also parallel to FC, that is part of CD. AB is parallel to FC. So those two angles are located between the parallel lines AB and CF, therefore they are equal to each other according to the rule that I already mentioned. Alternating angles that are located between parallel lines are equal to each other, therefore this angle equals to this angle. This angle is 2 theta, so this angle will be also equal to 2 theta. And we also know that all the angles inside a rectangle are right angles, so those three angles are right angles because ABCD is a rectangle. So we focused on the right triangle, triangle ABE. I draw again this right triangle. We defined AE as x. So if AE equals to x, then ED will be also equal to x because it is given us the question that AE equals to ED. So if AE equals to x, then ED will be also equal to x. So AE equals to x according to our definition. BE equals to 7 units. It is given us the question, and this angle is also angle theta. It is also given us in the question. So in this right triangle, triangle ABE, sinus theta equals to x over 7. This is equation number 1. And in the right triangle BFC, in the right triangle BFC, sinus 2 theta equals to 2x over 9. Again, in this right triangle BFC, sinus 2 theta equals to 2x over 9. Okay, equation number 2 states that sinus 2 theta equals to 2x over 9 in the right triangle BFC. And according to equation number 1, sinus theta equals to x over 7. And we have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosine theta. So here we have equation number 2 that says that sinus 2 theta equals to 2x over 2. So we can substitute sinus 2 theta by 2 sinus theta cosine theta because it equals to sinus 2 theta. So we substituted sinus 2 theta by this expression, and we got that 2 sinus theta cosine theta equals to 2x over 9 according to equation number 2. But according to equation number 1, sinus theta equals to x over 7, so we can substitute sinus theta in this equation number 2 by x over 7 according to equation number 1. So we did it and we got that 2 times sine theta is x over 7 times cosine theta equals to 2x over 9. Here we divided this equation number 2 by 2x because we have 2x in both sides of the equation, and what is left from equation number 2 after we divide it by 2x, what is left, it is actually cosine theta over 7 equals to 1 over 9. We multiplied the equation number 2 by 7, and we got that cosine theta equals to 7 over 9. Actually, cosine theta equals to 7 over 9 means that we have the relationship in a right triangle. The hypotenuse is 9 units and the side that is near angle theta is 7 units, and this is angle theta. We want to find out the side that is in front of angle theta. We will use the Pythagoras theorem according to the Pythagoras theorem, s squared plus 7 squared equals to 9 squared. We subtract that 7 squared from this equality and we got that s squared equals to 81 minus 49. 81 minus 49 is 32, so s squared equals to 32. We took a root from this equality and we got that s equals to square root of 32. 32 is 16 times 2, so the square root of 16 is 4. So in conclusion, we found out that s equals to 4 times square root of 2. And if s equals to 4 times square root of 2, then sinus theta will be equal to 4 times square root of 2 over 9. Okay? Sinus theta equals to 4 times square root of 2 over 9. Okay? Again, sinus theta equals to 4 times square root of 2 over 9. And we have already found out that cosinus theta equals to 7 over 9. Then we focused again on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that sinus theta equals to x over 7. Okay, you can see that sinus theta equals to x over 7, but we have already found out that sinus theta equals to 4 times square root of 2 over 9, so we can substitute sinus theta by this expression. So we did it and we got that 4 times square root of 2 over 9 equals to x over 7. We multiplied this equation number 1 by 7, and we got that x equals to 28 times square root of 2 over 9. Here x equals to 28 times square root of 2 over 9. Here also it is x, and if x equals to 28 times square root of 2 over 9, then 2x will be equal to 56 times square root of 2 over 9. Then we focused again on the right triangle, triangle ABE. So we found out that x equals to 28 times square root of 2 over 9. And on the same right triangle, triangle ABE, as you can see here, cosine theta equals to AB over 7. Okay, cosine theta equals to AB over 7. Okay, here cosine theta equals to AB over 7. But we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta by 7 over 9. So 7 over 9 equals to AB over 7. We will multiply this equation by 7 and we got that AB equals to 49 over 9. Okay, AB equals to 49 over 9. And we know that AB equals to DC according to the rule that the opposite sides of a rectangle are equal to each other. So if AB is 49 over 9, then CD will be also equal to 49 over 9. Okay? And then in the right triangle, triangle BFC, this right triangle, triangle BFC, cosine 2 theta equals to FC over 9. Cosine 2 theta equals to FC over 9. Okay, cosine 2 theta equals to FC over 9. We multiplied this equation by 9. And we got that FC equals to 2 times cosine 2 theta. And we have the trigonometric identity that cosine 2 theta equals to 2 times cosine square theta minus 1. And so we can substitute cosine 2 theta in this equation by 2 times cosine square theta minus 1. So we did it, and we got that FC equals to 2 times 2 times cosine square theta minus 1. And we know that cosine theta equals to 7 over 9, so we can substitute cosine theta here by 7 over 9. So we did it, and we got that FC equals to 2 times, and cosine theta is 7 over 9, so cosine squared theta will be equal to 7 over 9 squared minus 1. Then, so 7 over 9 squared is 49 over 81. So we got that FC equals to 9 times 2 times 49 over 81, and minus 1 is minus 81 over 81. Here we know that 2 times 49 is 98, so we got that FC equals to 9 times 98 minus 81 over 81. And we divided the numerator and the denominator by 9. 9 over 9 is 1, and 81 over 9 is 9. So in conclusion, we found out that FC equals to 98 over 81 over 9. That is to say, 98 over 81 is 17. So in conclusion, we found out that FC equals to 17 over 9. FC equals to 17 over 9. So if FC equals to 17 over 9, then DF will be equal to CD minus FC. Okay, DF equals to CD or DC minus FC. That is to say, DF equals to CD, that is 49 over 9, minus FC, that is 17 over 9. And 49 over 9 minus 17 over 9 is 32 over 9. So we found out that DF equals to 32 over 9. Okay, DF equals to 32 over 9. So we actually have all the values of all the sides of trapeze ABDF, so we can easily find out the value of the green shape that is actually the area of the trapeze ABDF. And found out that the area of trapeze ABDF equals to the sum of its sides, that is to say AB plus DF times the height, that is AD, over 2. It equals to AB plus DF times AD over 2. AB equals to 49 over 9. DF equals to 32 over 9. It equals to 32 over 9. AD equals to 2x, that is to say it equals to 56 times square root of 2 over 9. All divided by 2. 49 plus 32 is 81, so it is 81 over 9 times 9, all divided by 2. 81, 9 times 9 is 81, so 81 over 81 is 1, so this expression will cancel, and we left only with 56 over 2 times square root of 2. 56 over 2 is 28. So in conclusion, we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, so that was the second method. Then we found out the area of this green shape according to the third method. According to the third method, actually we drew perpendicular from point E to BF, so this angle is 90 degrees and this angle is also 90 degrees. Then we proved that those two right triangles can go into each other. Okay, so we proved the triangle ABE can go into triangle BME. Why they can go into each other? First of all, we know that those two angles, they are equal to each other, they are both equal to theta. So angle BAE equals to angle EBM equals to theta. Those two angles, they are also equal to each other, they are right angles. So angle BAE equals to angle EBM equals to theta. Angle BAE equals to angle BME equals to 90 degrees. Both those two angles are right angles. And angle BAE equals to angle BEM according to third angle theorem. Those two angles, they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles of one triangle can go into two angles of another triangle, then the third pair of angles must also congruent. And we actually proved that those two angles in triangle EBM congruent to those two angles in triangle ABE. So we have two pairs of angles that are congruent. Therefore, the third pair of angles, those are the third pair of angles must also congruent. That is to say, this angle must be equal to this angle. That is the third angle theorem. So we prove that all the angles of this triangle congruent to all the angles of this triangle. And we also know that BE equals to BE. It is a common side that belongs to both triangles. And we actually proved that triangle BAE congruent to triangle BEM according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that AB equals to BM. AB equals to BM, and if we define AB as Y, then BM will be also equal to Y. BM also equals to Y, and then we can conclude from the fact that those two triangles congruent to each other that AE equals to EM. According to the rule that corresponding angles and congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides will be equal to each other. That is to say, AE equals to EM. And if AE equals to X, then EM will be also equal to X. Okay? And we know that AE equals to ED. It is given us in the question. If AE equals to ED and AE equals to X, then ED will be also equal to X. So we found out that AE equals to EM equals to X, and AB equals to BM equals to Y. Then we connected together, we joined together points E and F by straight line, and we proved that those two right triangles congruent to each other. We proved the triangle EMF congruent to triangle DEF. Why they congruent to each other? Because first of all, we know that angle EMF equals to angle EDF equals to 90 degrees. Those two angles are both right angles. EM equals to ED equals to X. ED equals to EM equals to X. We have already proved it. And EF equals to EF, it is a common side. So we actually proved that those two right triangles can go into each other according to rule number 5. Rule number 5 states that if the hypotenuse and the perpendicular in two right triangles congruent, then the two right triangles congruent to each other. And we actually proved that the hypotenuse EF and the perpendicular ED in the right triangle EDF congruent to the hypotenuse EF and the perpendicular EM in the right triangle EMF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. We proved that triangle EMF congruent to triangle EDF according to rule number 5. And from the fact that those two right triangles congruent to each other, we will conclude that MF equals to FD. MF equals to FD. But we have already found out that MF equals to 9 minus Y. From this equality, we will conclude that FD also equals to 9 minus Y. And according to the rule that the opposite sides of a rectangle are equal to each other, it means that AB equals to DC. So if AB equals to Y, then DC will be also equal to Y. So if DC equals to Y and DF equals to 9 minus Y, then CF equals to DC minus FD. Okay? FC or CF equals to DC minus FD. We know that DC equals to y and df equals to 9 minus y, so fc equals to, we open the bracket here, and we found out that fc equals to y minus y is plus y. So fc equals to y plus y minus 9, so fc equals to 2y minus 9. So we found out that fc equals to 2y minus 9, and we know that the opposite sides of the rectangle are equal to each other, so AD equals to BC. So if AD equals to 2x, then BC also equals to 2x, and we know that CF equals to 2y minus y. And we focused on the right triangle ABE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is EB. EB square, EB is 7, so 7 square is 49, so the square of the hypotenuse is 49. It equals to the sum of the squares of the perpendiculars. That is to say, it equals to AE square. AE equals to x, so AE square is x square, plus AB square. AB is y, so AB square is y square. So in conclusion, we found out that according to equation number 1, x square plus y square equals to 49. Then we focused on the right triangle BFC, and the right triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is FB, and it equals to 9 units. So the square of the hypotenuse is 9 square. 9 square is 81, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CF square. CF square, CF is 2y minus 9. So CF square is 2y minus 9 square plus BC square. BC equals to 2x, so BC square will be equal to 2x square. So in conclusion, we found out that according to equation number 2, 81 equals to 2y minus 9 square plus 4x square. We open the brackets on this side of equation number 2, and we found out that 81 equals to 2y minus 9 square equals to 4y square plus 81 minus 36y plus 4x square. We have 81 on both sides of equation number 2, so 81 will get cancelled. So we got that f square equals to, according to equation number 2, 0 equals to 4. We took a common factor of 4 from these two expressions, and inside the brackets we have x square plus y square minus 36y. So here we know that according to equation number 1, x square plus x square equals to 49. So we can substitute x square plus y square from equation number 1 by 49 from equation number 2. We did it, and we got that 0 equals to 4 times 49 minus 36y. So we got that 36y equals to 4 times 49. We divided this equation by 4, and we divided this equation by 4, and we got that 36 over 4 is 9, so it is 9y equals to 49. We divided this equation by 9, and we got that y equals to 49 over 9. Y equals to 49 over 9, and we have equation number 1 that says that x squared plus y squared equals to 49. So x squared, and we know that y equals to 49 over 9, so y squared will be equal to 49 over 9 squared, and it equals to 49. We subtracted 49 over 9 squared from this equation number 1, and we got that x squared equals to 49 minus 49 over 9 squared. So x squared, 49 is 7 squared, so we got that x squared equals to 7 squared minus 49 over 9 squared. And according to the algebraic identity that a squared minus b squared equals to a plus b times a minus b, here b squared equals to 0 and a equals to 7 and b equals to 49 over 9. So in conclusion, we found out that x squared equals to 7 plus 49 over 9 times 7 minus 49 over 9. Here we multiplied 7 by 9, and then we divided by 9 in order to overcome a factor with this expression, and we got that x squared equals to 49 plus 63 over 9 times 63 minus 49 over 9. 49 plus 63 is 112, and 63 minus 49 is 14. So in conclusion, we got that x squared equals to 112 over 9 times 14 over 9. 112 is 8 times 14, so we wrote it down that x squared equals to 8 times 14 over 9 times 9. 8 is 2 times 2 times 2, so we substituted 8 by 2 times 2 times 2, and we got this expression. We took a root from this expression, and we got that x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9. The square root of 2 times 2 is 2, and the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. So in conclusion, we got that x equals to 2 times 14 over 9 times square root of 2. 2 times 14 is 28. So in conclusion, we got that x equals to 28 over 9 times square root of 2, and y equals to 49 over 9. Okay? And the area of the green shape, it is actually the area of trapeze ABDF. It is actually AB plus DF times AD over 2. There it's AB plus DF times AD over 2. AB equals to y. DF equals to 9 minus y. So AB is y plus DF, that is 9 minus y, times AD, that is 2x over 2. Y minus y is 0. And 2 over 2 is 1. So in conclusion, we found out that the area of the trapeze ABDF equals to 9x. Because here y minus y is 0, and 2 over 2 is 1. So what is left is only 9x from this expression. So the area of trapeze ABDF equals to 9x. And we have already found out that x equals to 28 times square root over 9. So here 9 over 9 is 1, so we got that the area of the green shape ABDF, or trapeze ABDF, equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay? The area of this trapeze ABDF equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay? Thank you very much.